Okay, so here's some more practical tips. First is you perform in-depth EDA or exploratory data analysis. There's so much insights that you could get by just doing EDA. For example, you could already see some of the correlations or the trends just by looking at the graphs that you create in your EDA. And that can already be used for uh, recommending something to the different stakeholders that you have in the project that you're doing. And also by doing EDA, you could already see some of the feature engineering techniques that you might have to do in your data set. Next is data leakage. So this is very important. And most practitioners out there do forget this part here. So the first recommendation for that is to split the data before you do any imputation. The main idea is that you make sure that the test set never affects the modeling process. So split the data set first before you do anything. Really, that's the right way to do things, and that's how we avoid data leakage. So here's the common machine learning pipeline. You do data cleaning, you split it, you do some imputation, then you do feature engineering, like scaling, and it's important that you do scaling before you do other machine learning techniques later on. It's the best way to do things. Just make sure that you scale it because other machine learning models do require that you scale the data first. And it's so easy to scale it back. So the best practice is to just scale it. Okay, so after doing the scaling, you do the modeling, and then you do some hyperparameter optimization, and finally your model evaluation. Also remember that there is no silver bullet. We use different techniques for different problems. And new techniques or platforms are made every few months. It's so hard to keep up with the advancement in this field. But the thing is, the core doesn't change. The math, stat, and core algorithms rarely change this field. So it's really important that we have very good foundations because you can just keep up with all the things that are happening right now. Like, for example, ChatGPT that was just created, or at least was published back in November last year. Let's see the developments that have happened since then. And finally, don't stop learning. Play around with open source data. Create your own projects, something that you're really passionate about so that you learn more. In my case, I did lots of analysis related to games because I'm a gamer. And then I am into robotics, so I did lots of those projects as well. So I integrate hardware, software, AI, and whatnot. And that's it.